So hi, I'm in the process to complete the rebuild of this Ryobi battery, and I want to show you how it looks. What I did basically, removed the old cells that were inside this battery from AliExpress. The BMS looks very good and nice build, so I would like to use it, and I put VTC6 Sony lithium cells, which are capable of high current, and I'm in a process to complete this battery rebuild, and I will show you what I'm doing. So I put because I don't have nickel for 4 cells, so I built it. It's not the best way, but it's better than nothing. So let's complete. I'm using a very high current output in order to be able to rebuild this. And what I'm doing, I'm using a nickel strip of 0.15 millimeters, which is quite a thick one, but this is because the battery will handle a high current. So what I'm usually doing, I'm taking these nickel strips and I just cut them, and I remove the sharp edged, because sharp edged are not good and they can cause short. Another thing that I'm doing, these cells are completely discharged, so I discharge them completely, all of them, also in order to be able to connect them, because if they're in parallel, so the voltage should be the same for each cell that is in parallel. So what I'm doing, I'm just cutting the edge sharps. I can't do it a complete circle, but this is what I can do, let's say, with the tools that I have. So now I'm using a magnet to catch, as always, the nickel in its place. Also, I've added these isolators that I have from other cells. You can order them. This is another layer of protection, especially in the positive edge, that can be shorted. So again, let's do the very last welding for these cells. So again, I'm using it on a very high current. You can see that it can melt the nickel strip, although it's very thick. So I'm sure that it will be okay. And again, it's better thing to take quad nickel strip from AliExpress order, and then you just cut them and you don't need to do the stitches as I'm doing right now, because I don't have any other options currently. So again, I have the 2 last cells which were completely discharged, and of course be careful not to do any short. It's very simple. If this is the plus, so the next will be the minus, because plus is going to the minus in order to get the total voltage. So I'm just entering the cells to the place. It's a little tricky, but it does fit. I need to use, if I can't do it, so what I'm doing, I'm taking the cell from the other side and then see that it can fit in, and then I re-enter from the other side, and usually it's okay. So I have the last strip. So what I need to connect now is this 4th and then this one, and I'm complete. So maybe I will start with the last connection to the cell itself, to the board PCB. So again, same process. And again, this is the positive, so I want to add the isolation. So I'm adding 2 isolations for the positive side. And now I'm in a better confidence that it will not cause any short. Okay, so again, high current indeed. And from time to time I also clean, not clean, I remove some part of the copper with this motor that is cleaning the surface, and it's better that the copper is very sharp. And so this way the welder is much better. Okay, you see. So the last connections that I need to do is from this to this, and then I complete. Of course, then I need to connect the balancing wires. So I will cut another 4 parts, and then I will be able to complete this battery. So I did cut another 4 pieces, and now is my last welding. So I check very carefully that I'm not doing any short, and this parallel to this. So first I will connect those together, and again using a magnet. To catch it. So now again with very high current out, you can see the weld is very deep, and it is melting in high current the battery surface. Okay, so now I need to connect these 2 together in parallel, and then this to this, and then I completed all the process. So let's do this part here. You can see the second weld is a little less deep because the capacitor discharged, so you need to wait a few seconds when you're working with high current. I did forget something, but I complete it now. Again, I did forget to put the isolators, but since I did not yet weld the other side, so I can put it into its place like this. Yeah, and then also on the other side. Yeah, and last step is this welding, the last one, and I'm checking very carefully that everything is in the correct order, and then positive to negative, and then the battery will be complete. It's also a good practice to put it to see that there is no short. Yeah, you see there is no short, no spark before starting the last weld. Okay, last one. Okay, now basically the last step, of course, is to connect all the BMS wires. By the way, it is not yet showing the LEDs because probably I did not yet connected the wires of the balancing. So this will be the real last step. So let's do it right now. Another good thing, of course, is to take a meter and to see that the positive and the negative, the voltage is okay, as you can see. So now I will use the soldering and connect all the balancing wires. So really last step here. This part is with a soldering iron. Okay, so I have here something because my other solder was broken and I'm waiting for some parts, but I have something meanwhile to use. Okay, so let's do it. So this is the first, this is the third. I'm already in this side, so I will complete this side. And of course the last step is to charge the battery and see that it is okay and it is charging. So I have here, okay, the 7.4 here. Note that I'm always soldering on the negative side and not on the positive, because the positive you can do a short, and on the negative, let's say it's better. Let's see now, and as you can see the LED is lighting. So now we need to charge, of course. It's completely discharged. I will put everything back and then see if this is working. Okay, so now let's close everything back. Hope I remember how it was. I did put some Kapton here, and I did put what left from this part. I think it's in order to avoid that the battery will move, or I don't know what. And now we'll put these plastic parts. Now I know what this is for. This is in order. Aha, now it's a little difficult to take it out. I will add a little Kapton because I see that these metals are in the side of this part, and if the metal will break and you press it, you can do a short. So what I'm going to do, I have an idea. Yeah. I have this very strong paper. It's a laser paper or something like this. If I will be able, I can insert it this way. Yeah. This will be extra safety to avoid short if something is breaking here. I'll do also on the other side. Now I'm pretty confident that no matter what happened, this will not do any short. Yeah. Good idea. Now I will put this plastic back. These are used in order to press and remove the battery. Yeah, and now close everything back. Yeah, everything looks rugged and nice closed now. Last thing is, of course, to see that this battery is charging okay. After I fully discharge it, and see that it is working properly and nothing is hitting. Okay, so the battery is completely charged, and now I can show you. Looks okay to me. Now I will put it in a welder. This is a very high power consumption, so let's see if it is working. If nothing is exploding, the battery doesn't get warm anyway. This is a very high current consumption. We'll wait to see if it is getting heated. Yeah, it looks like it is heated already, and you can see that it is working. Let's wait till the welder get to its temperature and the LED will stop blinking. And just check is the battery doesn't get hot. It's totally cold. So you can see worked well. The older battery didn't hold charge and stopped working after a few minutes or two with this welder. So yeah, it looks like it is okay. Okay, if you're doing it, be very careful. Know very good what you are doing. Fully discharge the battery. Pay attention to all the details I have showed in this video, how to do it correctly. Put isolation, be careful, and have a nice week. Bye.